Hello students, in today's video we're going to be working on L'Hopital's rule. So in your book this is section 9.2. So let's go ahead and get started. Now we use L'Hopital's rule to help us figure out or determine the limits when we have what's called an indeterminate form. Now when we're attempting to do a direct substitution into a limit of a form, so if we take a look at the example here, anytime we have the limit as x approaches a, for f of x divided by g of x. If that ever yields 0 divided by 0, or infinity divided by infinity, we call that the indeterminate form. Now, that makes it really difficult for us to find these limits because direct substitution doesn't really give us anything. So, what we're using to help us figure these rules out, or these limits out, is the L'Hopital's rule. Now, this may only be used for indeterminate forms. So remember, this can only be used when we do a direct substitution, and that gives us 0 divided by 0, or infinity divided by infinity. So when we use L'Hopital's rule, we take the derivative of the top and the derivative of the bottom. So keep in mind, we're not using the quotient rule, we're literally just taking the derivative of the numerator and denominator separately. So let's go ahead and take a look at the next problem. So in example 1, we have the limit as x approaches infinity, as x approaches in 0 from the positive side, where we have 1 minus cosine of x divided by x squared. Now you'll notice here, this is saying it's coming from the positive side. What's going to end up happening here is if we substitute 0 in here directly, we're going to have the indeterminate form because cosine of 0 is 1. So 1 minus 1 is 0, and 0 squared is 0. So we're going to go ahead and use L'Hopital's rule here. So when we do that, we're going to take the derivative of the numerator, which is f of x equals 1 minus cosine x, and we have g of x, which is equal to x squared. Now, what happens here is when we take the derivative of each function, we know that derivative of cosine x, or derivative of f of x, that's equal to sine of x. We know the derivative of g of x, or g prime of x, is equal to 2x. Now, what ends up happening here is if we substitute these values in, 0 coming in from the positive side, we find out that this doesn't work, because if we substitute in 0 directly, 2 times 0 is 0, which gives us a undefined already. So what we're going to do is, since it is coming from the positive side, we are going to substitute a value in here. So f prime of x, or rather, instead of x, we're going to substitute 1/10, because that's approaching 0 from the positive side. So we end up getting sine of 1/10. And we do that for g prime of 1/10. We get 2 times 1/10. And when we simplify this, sine of 1/10 is pretty darn close to 0. So we're going to say 0. And then when we divide that by 2 times 1/10, that turns out to be 1/5. And so when we do all this multiplication, it turns out that our limit here is 0. So luckily you won't have to deal with that too much. You can also verify this on your calculator. Let's go ahead and look at another problem. So here we have something that should be a little bit easier to see. You'll notice if we substitute 2 in for these values, we're going to end up getting an indeterminate form, or 0 divided by 0. Again, that's not going to work for us. So what we're going to do is we're going to take the derivative of each piece. So f of x equals x squared minus 4x plus 4, all divided by g of x, which is equal to x cubed minus 12x plus 16. Now, when we take the derivative of each piece, we're going to get 2x minus 4 and g prime of x is going to be equal to 3x squared minus 12. Now what we're going to go ahead and do is substitute these values in now. So when we substitute 2 into the function, we end up getting 2 times 2 minus 4. Well, that's equal to 0. And when we substitute 2 into the g of x, we get 3 times 2 squared minus 12. This actually gives us 0 as well. So when we run into instances where we get 0 or another indeterminate form based off of the first derivative, our next step is take the second derivative. So f double prime of x is actually equal to 2, because I looked at the original function and took the derivative of that. And then g double prime of x is equal to 6x. Now what we're going to do is go ahead and substitute that in. So we know that f double prime of 2 is equal to 2 because there was no variable to substitute. And g double prime of 2 is equal to 12. So when we simplify this, we know that the limit as x approaches 2 is going to be 2/12 or 1/6. So this is going to be your limit. Let's try one more problem here. Now we have the limit as x approaches 2 for x minus 2 divided by x squared minus 4. Now, what we're going to do is if we substituted the 2 in here, you would know 2 minus 2 is 0, and 2 squared minus 4 is also 0. So we're going to go ahead and use L'Hopital's rule one more time. We're going to get f of x equals x minus 2, g of x is equal to x squared minus 4. So f prime of x is equal to 1, and g prime of x is equal to 2x. Therefore, when we substitute the values in, so g prime of 2 is equal to 1, and g prime of 2 is equal to 2 times 2, which is 4. Therefore, the limit as x approaches 2 for that function equals 1/4. So I hope this is much easier than what you're used to seeing for now. Remember, we can only use this on indeterminate forms. So let me leave you with one extra thing. Now, other indeterminate forms will look like the following thing. 0 divided by 0, infinity divided by infinity, infinity times 0, infinity minus infinity, 1 to the infinity, 0 to 0, or infinity to the 0 power. So for forms other than these, we can first use algebra to change the form, then use L'Hopital's rule. So we're not going to talk about this too much because it is a Calculus BC topic, but I wanted to make sure you're exposed to it because it's going to be helpful when we have more difficult limits to take. So that's all for now. I'll see you guys next time.